All right, I'm going to model for you not only what I expect you to do on these problems, but how I expect you to know what to do. So the first thing that it wants us to do right here is sketch a graph, okay? But before I do that, I'm going to gather this information down here before I begin sketching it, okay? So my factors here that they're given to me, that factor is x plus 2 and that factor is x minus 1. That means I have a 0 at negative 2 and I have a 0 at positive 1. And if you've forgotten why that is because you take the zeros, you take the factors, you set them equal to 0 and you solve. So by solving that, I see that my 0 is at x equals negative 2. By solving this one, setting it equal to 0, and then solving, I find my 0. Okay, so that's where I got those. The multiplicity is determined by this up here. This has an exponent right here of 1. This has an exponent of 2. So this has a single multiplicity. You can write the word single right there. Or you can put the number 1. And then the x minus 1 has a multiplicity of 2. That multiplicity is how we know what the behavior is. And there's two behaviors right there, bounces or crosses. That's what we're going to put right here, behavior on the x-axis. If it has an odd multiplicity, it's going to cross. If it has an even multiplicity, it's going to bounce. Okay, now I only had 2 factors, so I don't need these extra things down here. They're if you have more than one factor. The end behavior, what do I look at the end behavior? I look at 2 things. I look at this positive x cubed. That's what I look at. So the fact that it's odd tells me that I have different end behavior. The fact that this is a positive right here tells me that it's up on the right. It's up on the right and down on the left. Okay, so the way that we write end behavior is to say on the right, my graph is going up. On the left, my graph is going to go down. So now that I have this information, now I simply put it on this x-axis. So you want to list your zeros on the x-axis. Be sure you list them in numerical order. So that means the negative 2 goes first and then the 1. I'm not really interested in scaling. I mean, you can like put your little tick marks. Well, that might be better. Let's do that. So you can find a spot on here. It doesn't matter where. Find a spot on here. Let's call it 0. 0 does not have to go in the middle. You can put 0 wherever you want. Let's put 0 over here. I don't know why. And that's going to be positive 1. So that's going to be negative 1. And this is going to be negative 2. And that's really all I need. You can do more. You can put 2, you can put 3. There's no rules here that say you have to fill this all in. The only ones that I have to see negative 2, and it needs a pretty substantial dot right there, and I have to see positive 1. It needs a pretty substantial dot right there, and then you have to put your end behavior. We said that on the right side it's going to be going up, and on the left side it's going to be going down. Then I have to see the behavior on the x-axis. Remember, your graph cannot cross the x-axis. anywhere else. Those are the only two places. So we said right here at the -2, it's going to cross. So our graph is going to go up over here on this other side. And right here, we say it's going to bounce. So that means there's our turning point. Okay? And that means that in order to complete this graph, we need for it to connect somewhere. So you just connect the things. That's kind of ugly. Let me make that a little bit prettier. Okay, you're just going to connect those. This is going to go here and turn around and come back. So I don't know how high it is. I don't know anything else, but this is what I know. I know the end behavior. I know the behavior on the x-axis. I know how many times it's crossing the x-axis. So this is an appropriate model for this piece of information.